In today's session, we'll be discussing some basic mathematics which is required for your 11th and 12th physics. In physics, as we'll see, we'll be applying a lot of maths in physics because maths is the language of physics. Maths is the tool which you'll be using to communicate all your laws of physics as such. So when you want to study physics, before that we'll be reading some basic maths which you'll be using over there in all your physical chapters which will follow, right? So we'll start off with one basic mathematical concept which you'll be using later in physics, and that is trigonometry, right? So let's start with what the study of trigonometry is about. So as you're probably aware of, your study of trigonometry is the study of angles, right? In trigonometry, you basically study about angles, and what you've studied in 10th is you read about sine theta, cos theta, tan theta, so on and so forth. So the theta over there, that's the angle over there, right? So first of all, let's define what an angle is. So an angle is something which you get when you have two lines intersecting. When you have two lines intersecting at a point, you say that this is the angle which is there in between these two lines. So this is basically what you define as an angle, or this is your figure, your graphical representation of what an angle is. That is something in between these two lines, right? But you have a more technical definition for what an angle is. So let me write down what your technical definition of angle will be. We define your angle to be equal to your arc length divided by the radius. This will be a more formal definition or a more technical definition of what an angle is. Your angle is defined as the arc length divided by radius, right? Now in the figure which you have drawn where we have two lines intersecting, you neither see an arc nor you see a circle over there, right? So how is this definition valid over there? So let me explain how we can apply this definition for this particular case. Let me imagine now I'm drawing a circle of radius r. So imagine you have a compass, take a compass, right? And place one point of the compass at your point O and take a certain length now. You can define whatever length you want it to be. So let me take a length of r over there, where r can be any value. It can be 10 centimeters, 20 centimeters, whatever you want it to be, right? And now imagine that you're drawing a circle. Imagine by taking that compass, you're drawing a circle over there of that radius r. So you get an arc over here now in between these two lines. You get an arc over here in between these two lines. So this arc length which you have, that divided by radius, you see that will be equal to the angle, right? That will be equal to the angle between the two lines. And one more thing which you'll observe over here is, no matter what radius of the circle you take, if you take another radius now, you take a bigger radius and draw an arc, you will see that the ratio of that arc length by the radius will be equal to this arc length by radius. That will not change over here. So that will remain a constant for a given angle. So anyways, this is your more technical definition of what angle is. Your angle is defined as the arc length divided by the radius over here, right? So this is the formula of angle you should remember right now. And you'll observe that when you find out the angle in this way, when you find out the angle by using this formula, you'll get the angle in a different unit. What's the unit of angle you're familiar with till now? The unit of angle which I've been using till now is degrees. You say that the angle is 45 degrees, 30 degrees, 60 degrees, so on and so forth. But now in 11th and 12th physics, we'll be using a different unit of angle, or the formula which you'll get when you use this formula to find out what the angle is, you'll get the answer in a different unit, right? So the SI unit. So SI unit is basically the scientific unit, the unit which the scientific community uses for that particular physical quantity. Is the internationally accepted scientific unit, is basically what that means, right? So SI unit of angle is not degrees, or the unit which is used for angle in the scientific community is not degrees, it is radians. Your SI unit of angle is radians, right? So in today's session, we'll try to concentrate on how to convert an angle in degrees to an angle in radians. So radians is what you should get familiar with right now. You should first be able to express whatever angle you have. You should be able to express that angle in radians, right? So that is what we'll be trying to practice here today. That's what we'll try to get a hang of today. Whatever angle is now being given to us. For example, an angle of 45 degrees is given. So degrees is the unit we're using over there. So how do we write that angle in degrees, or how do we convert that angle in degrees to an angle in radians is what we'll be looking at, right? So before we go to that, let's take a simple case and let's try to see the answers for that case. Let me take this formula and apply it for one particular case, right? So let's say I have a straight line, or maybe let's say I have two straight lines arranged in this manner. So let me take a straight line OA and a straight line OB, right? So two straight lines arranged in this manner, right? And let's say that you have a semicircle between them. So basically I'm saying that the length OA is equal to length OB, right? So if I now draw an arc just like I've drawn an arc between these two lines, Let me draw an arc in between these two lines now. Let me draw an arc in between these two lines, right? And now basically I've drawn an arc of radius r over here. Let's say that the radius of this arc is r, right? So now if I want to find out what is the angle between these two lines, if I want to find out what is the angle between these two lines, I already know the answer for this. You're already familiar with the answer for this. You will say that the angle between these two lines will be equal to 180 degrees. You will say that the angle between these two lines is 180 degrees, right? And this is something with which you're familiar with. You've already read it in your previous classes, right? But now let me use this formula. Let me use the formula of arc length by radius, and let's see what answer that gives us, right? So how am I using the formula of arc length by radius? How have we used that formula over here? We'll draw an arc in between these two lines. So now I want to find the angle between these two lines. So let me consider a circle of radius r, and let me draw an arc of radius r right now. Let me draw so these are two straight lines over here, OA and OB. So let me draw an arc of radius r in between these two straight lines. Let me draw an arc of radius r in between these two straight lines. What is O here? Once again, O is the point of intersection of these two straight lines. Correct? So now I've drawn an arc over here. So now let me say that your angle. So what was the definition of angle now? Your angle is equal to arc length divided by radius. Your angle is equal to arc length divided by radius. So what will be the length of the arc over here? You're familiar with what this diagram is. This is a diagram of a semicircle. So what will be the length of a semicircle? What will be the perimeter of a semicircle? Your perimeter of a semicircle will be equal to pi r. It's half of your circumference of your circle. So it should be half of 2 pi r. So you get the arc length over here for this particular case. The length of this arc over here will be equal to pi r. And that divided by r will give you the angle, right? But you see that you're not getting the answer is 180 degrees. You're getting the answer is pi r, right? So when you use this formula, when you use the formula for angle is equal to arc length by radius, you get the answer in terms of radius. You get the answer in terms of radians. So here, that is the SI unit of angle. So here we'll say that the angle between these two straight lines is pi radians. The angle between these two straight lines is pi radians. And from this, can I come to one conclusion? Now I know that the angle between these two is 180 degrees, right? That is the angle mentioned in terms of degrees. Now I also know that the angle between these two straight lines, and I've used this formula, I got that answer to be equal to pi radians. Please remember this point, when you're using this formula, when you're using the formula arc length divided by radius, you'll always get the answer in radians, right? So I've used that formula over here. So I got the answer as pi radians. So can I say that pi radians right now will be equal to 180 degrees? The pi radians is equal to 180 degrees because both of them are basically measuring the same thing. You say that the angle between these two straight lines is 180 degrees, and you also get the angle between these two straight lines by using the formula as pi radians. So this is one formula which you have for one conversion, that is pi radians is equal to 180 degrees over here, right? So you see how we are using the formula to get the angle, and when you use the formula to get the angle, you'll always get the answer in radians, right? Now, fine. So this is one thing. I hopefully you understood this case. Now I don't want to do this all the time. For example, we want to find the angle between these two lines, and if we want to find the angle between these two lines in radians, right? Here your arc length was pretty easy to measure because we already know that it's a semicircle, so I know what the arc length of a semicircle is. But in this case that will become complicated. So rather than always doing this to find out the angle in radians, rather than always using this formula to find out the angle in radians, let us now look at a formula to convert an angle in degrees to an angle in radians, right? So now look at a formula to convert an angle in degrees to an angle in radians. So let me write down that formula. So your formula for converting any angle in degrees to any angle in radians will be equal to, if you're given that an angle between two lines is x degrees, if you're given that an angle between two lines in x degrees, your x degrees can be converted into radians as multiply this x with pi by 180. Multiply this x with pi by 180. When you multiply this x with pi by 180, you get the answer in radians, right? So this will be your formula for conversion of an angle in degrees to an angle in radians, right? So if you have an angle given in x degrees, multiply that angle given in degrees, that is your x value, with pi by 180. When you multiply this pi by 180, whatever answer you get from this, that will be an answer for the angle between these two straight lines in radians, right? So let me take the previous case. Let's verify if this formula is correct or not. For example, what is 180 degrees equal to now? We already know that the answer for 180 degrees should be equal to pi radians. That was the previous case we had taken. Now let's see if this formula will give us a correct answer. So what is 180 degrees equal to in radians? 180 degrees will be equal to in radians as 180 degrees into, 180 into pi by 180 radians, right? 180 gets cancelled. So we get 180 degrees to be equal to pi radians. Your radians can be written as rad in short. That's the, just like you write meters as just m in short, right? So write radians as rad in short, it means radians only, right? And now you can see how we have applied this formula to get a result which we already know. That is 180 degrees is equal to pi radians. So let us take other angles. Now you should be familiar, you should now get used to writing all these angles in radians, because that is the unit we'll be using mostly in physics later, right? Anyway, so now let us take different angles. What is 90 degrees be equal to? Then we use this formula. So what is 90 degrees equal to? 90 degrees will be equal to 90 into pi by 180 radians. 90 into pi by 180 radians. So 90 divided by 180 will be 1 by 2. So you get the answer for 90 degrees to be equal to pi by 2 radians. What will 60 degrees be equal to? 60 degrees will be equal to 60 into pi by 180 radians. 60 when multiplied by 3 gives you 180. So this is pi by 3. So get 60 degrees to be equal to pi by 3 radians. Right? So this is how you convert an angle in degrees to an angle in radians. Right? And this is something which you should get soon comfortable with, right? Because we'll be using radians more and more in physics. Rather than expressing an angle in degrees, we'll be expressing an angle in radians more and more, right? So this is the time for you to get comfortable with converting an angle in degrees to an angle in radians.